very important to explain this to people who are developers or future architects or other people. Don't be hung up about the technology you're planning to use, right?
Hi everyone, welcome back to another engineering podcast from O4S. I myself am John Sriek. I'm a dev here. We have Arjun Bahar also with us. He's calling in from Goa. Hi Arjun.
Hi, John. So I'm really happy to be here on this podcast with you as my co-host. Yeah.
Yeah. So could you tell me something about how your work is going on in O4S and what are you currently focusing on?
Yeah. So I think my journey with O4S started with writing middleware software for their printers, industrial printers. As we know that O4S, as a very critical part of their business, has to print QR codes onto the products at the manufacturing sectors. So, and that's part of the edge, aspect of things that we look at, which is on location where the factories are printing these, or serializing, as we term it, these labels, right, directly or onto the product. So I was writing the middleware software that would enable doing that. And now I'm, responsible for Edge in general in terms of helping scale and also reducing the operational issues that we have, and over time focusing on automation and also basically focusing on scale and reducing operational issues and risks. Yeah.
Great, great. Cool. And I am currently working on, these. There's a project for onboarding and batch processing. So we have certain workflows and background processes that we have to kind of scale out. And the current existing systems are kind of bottled. We're finding bottlenecks there.
So
That is
John,
what I'm focusing on.
I think just for everyone's benefit, I think just earlier on when we joined, I think Johns and I had the pleasure of working, and then I think in the middle 2 years, Johns, you went out, and it's really great to have you back on O4S, as part of the team, and here we are again working together. So I think it's really and it's exciting times for O4S to work together. But taking a step back into the past, right, when you worked here earlier, I think when you were trying to kind of set up the systems here, you guys were trying to create some batch flows, and you guys had employed the use of DASK as well as Prefect. Firstly, before we get into that, what were your use cases for the workflows that you had? What were the use cases that you had?
I guess in the ecosystem that we had three main use cases. One was for data syncing between different data stores, which were being done by cron jobs. And second was to have on-demand jobs batch processing, which when customers request certain data or wants to onboard some entities into our systems, uh, we take it as a background process, since these call different services in our systems, mesh service. It's kind of a heavy task, so we wanted to delegate it to this particular system, which individually handles each entity.
So from what I understand is you had various kind of jobs, and the issue was that you needed to kind of scale the running of those jobs, virtually, and so that you could process them in memory. And as the processing requirements increased, you could just simply add more probably virtual machines and scale that operation. And for that, you chose Dask, basically, correct?
Yes, scale. We had planned for scaling it out eventually.
Yeah.
Hence, since Dask looked like a good way to go, for scaling out eventually. So we had implemented some jobs in Dask, which later on turned out to be, not a good fit for us.
Okay. So can you explain to us why you felt, in fact, for I think a lot of people who don't understand what Dask is, of course, they can look it up on the internet. But I think one of the things that Dask does is I think, just give us a slight introduction, maybe a two-line introduction to DASK, and then what your lessons or your issues with DASK were, maybe with the implementation of DASK, if you could just tell us.
DASK is, I guess, can be defined as a framework which is written over pandas, basically, to distribute large data over multiple workers and work on them simultaneously. So, when you have big data stores like MongoDB or SQL DBs, the problem with that is to do some analysis over it. You don't know which columns should be indexed, right? When you don't know what data you're going to work on beforehand, you need to have it all at once together in ready for computation in memory. So Dask helps you with that to
So, for everybody's understanding here, a
yeah.
simple way to put it would be that typically we have databases, but when we want to load large amounts of information and do in-memory processing, especially on fields that are not indexed, then databases are not useful. We need to load it into memory and do the transformations in memory, and we can't burden any single virtual machine with that. At that point, I think Dask is able to parallelize the operations and kind of perform actions, something very much like Spark in the Java world, I think. So yeah, okay, understood. And what were so it seems like there's a lot of application, etc. But what went wrong? And that's exactly what is probably of interest here is what went wrong when we initially implemented us.
Right. So what our kind of the nature of our jobs that we wanted to do was to have, so we had a particular DAG of a flow of functions. Each function needed to get output from the previous function, right? And this could not be delayed, like because the processing of function as function two depends on the computed output from function one. As so, when you have data that needs to be computed and is dependent on further subsequent tasks, you cannot, DAS won't be able to help you there. We won't be able to delay those tasks.
Understood. So because there's a direct acyclic graph, that's the DAG, there are dependencies of nodes on the previous node. So if the node is stuck, then obviously the other nodes are not able to process the data, which basically implies that ideally a condition for DAS should be that you should have preloaded the data into memory for free flow or easy processing of that data without much interruptions. And I guess you guys were using depending a lot within the nodes for making database queries, which was causing the nodes to slow down in the DAG. Is that
Right, rightly said. We didn't have a use case in which we wanted to work on a big chunk of data. We knew which subset of data we needed to load, and which further on we were working on that data, which in turn fetched other data. So it was just a subset of data that we were working on. We didn't have the actual need for DAS.
So basically, a lesson for this could be that DASK is great for concurrency, but a prerequisite for concurrency is that there is mutual exclusion, and there is also within a single flow, there is not much delay between each step. And I think both were missing, because of which DASK, though great technology, was not the right fit then.
Right.
And also, I believe this led to a lot of implementation complexity, because the original Python scripts that were written for the ETLs, I think now had to be context aware of the DAG, which makes it really complex to code, right? And ideally, that's not how things should be done. Ideally, I should write my script and it should run, and the person writing the script should not be aware of the complexities surrounding that script for the most, apart from the fact that it will be run in a parallel environment. So I think there was also a lot of issues in terms of development complexity and knowledge curve, correct?
Absolutely right, Arjun. There were a lot of jobs written which didn't even consider that it was running on a DAS machine. So when you write a job, you need to know that where it is going to run, right? We cannot write just simple plain Python scripts for that. You need to use the task data frames, uh, which which themselves take care of distributing it evenly and delaying it.
Okay. And the other thing that we were using, so this is DASK, and I think the other thing was the orchestrator of the tasks, right? For which I think we evaluated Apache Airflow versus Prefect. Do you want to tell us something about the evaluation of the technology? And again, with Prefect, what went wrong?
Yeah, so when we were looking at an orchestration layer, like the need for an orchestration layer, as we all know, is like it's not just about writing the jobs, right? Where we need to monitor how and where they are performing. So Airflow and Prefect look like a good option. Airflow is much more stable, but it had a higher learning curve, and we didn't have enough resources or time available to do that R&D there. Prefect, on the other hand, was pretty lightweight abstraction of existing functions. We could just add a layer over existing functions.
So sorry to interrupt you, but what's very interesting actually that's coming out is that in both selection of technologies, it seems like there was no time to research the technologies and the technologies were applied prematurely. Because even over here, the key thing that you mentioned was that even though airflow seemed to be very poor, the learning curve was very high. And I think the investment of learning curve at that point wasn't there, which is what kind of prompted us at that point to use prefect, right? So I think in both cases, I think time was a constraint that means, yeah.
Well, that was one big nudge towards Prefect. There was also, certain community talks where evangelists had moved from Airflow to Prefect for certain so and so reasons, which are available on the internet.
I
Big
also see
debate
few
over
articles
there.
saying that okay, if they were using Airflow and now they're using Prefect, so maybe Prefect is a better choice, right? That kind,
Yeah. We when we attend community talks like that, we have a tendency to,
right? That happens. Yeah, we tend to follow talks and internet material more than our own research sometimes. And I think that highlights the importance of not always trusting what's online in terms of opinion, but research. Yeah. Excellent. So now coming, so since we selected prefect, maybe for the right or wrong reasons, it's hard to tell. But what were the lessons in the implementation of prefect? And again, I want to remind the viewers that there is no right or wrong technology. Often what goes wrong is in the implementation of the technology. So again, what I want to ask is what went wrong in the implementation of prefect with at O4S at that point?
the implementation. Yeah. So when we were implementing this orchestrator to run our jobs, for some reason we weren't able to get our dashboard running. So we kept it for later, and it got postponed again and again. And in the end, when we actually wanted to use it, we were not able to because how our jobs were written. Uh, so we couldn't use of the primary use case, like where for monitoring and visualization of our job runs. We were not in the able to use it in the end.
Okay, so one is that we didn't have the dashboard, which is primarily the reason why you want to use something like Prefect so that you could see all your jobs running.
Yeah.
So that itself was missing. And I think there's also the scheduler that was not used, right? Which should have ideally been used.
Right. Prefect themselves offer a pretty powerful scheduler. We, for some requirements, we thought it would be better to use our own scheduler for it, which was a bad choice. But we are currently moving into using the prefix schedulers again.
Okay.
We have bought up the bash. Yeah.
Okay, and also I think there were also issues because of the scheduler being a custom scheduler. Each time someone had to make a change to the schedule, they had to change the code, which led to like an entire release cycle just to change simple code configurations or schedule configurations. Is that right?
You did your research right. Yeah, we had that problem. A lot of such problems saying, when you want to disable a job, you need to go through the entire life cycle of release, which was a very bad thing. But we are working on moving away from that. We will be able to control all our jobs on the Prefect dashboard itself.
So again, so I guess this was all 2 years ago, right? So where has O4S today now? Where are we now with this and with the lessons that we've learned? what is the current work that we have produced and the work in progress? If you can highlight upon that a bit.
Right. Yeah. Since these was kind of giving a somewhat acceptable results somehow, we got the time to actually work on the correcting what we did wrong. So that's a point that I want to highlight. We got time to take a step back and look at what is going on right now. How can we implement it better? And what are the techs that we need to use right now? And we are doing a migration right now for deprecating the bad implementation, and if we are able to scale it out right now. Already, some jobs are running in production for it.
So just based on my research, I think what I found was, just to articulate what you said, to summarize it rather, is that the recommended way of using the prefect was to use the dashboard and its own scheduler, right? And creating those flows using the DAGs. We basically rewrote those flows without too much in-transit data, which was the mistake earlier on, right? And we also removed our over dependency on DASK, right? Because what we found out was that DASK was not really required for all tasks. So you can directly run those tasks by prefect, and only the ones that certain jobs, right, that need to be run by DASK were then finally identified and were running by DASK, right?
Right. That summarizes it.
Okay, and I think it also, there was some debugging issues earlier on because of the lack of dashboard, but now because we have a dashboard, we can actually real time monitor these processes running, and that improves the debuggability also of these processes, correct?
Yeah, we'll be able to pinpoint what particular, at which particular job is causing issues or how much memory it is using, because each jobs are going, our executor is Kubernetes right now instead of DASK. So each job runs in its own pod. Like say when the job is run, the pod is removed. So we have a Grafana setup on monitoring each, memory usage of each pod, CPU utilization, how long it is run. So we have visualizations from both from inside the job and outside the job.
So I have a question here. Given the fact that O4S is scaling rapidly, and we're going to have different clients, and we want to prioritize even within clients. We would like to, I guess, prioritize in the near future, jobs, the same jobs, like an ETL job for say client X, who's probably on a subscription plan, or on some sort of commercial plan, and versus a client B, who's on some sort of a different commercial plan, right? Where you want to kind of allocate more resources for the processes based maybe not just on the commercial plan, but based on the requirements, right? How are we able to kind of technically prioritize tasks from client to client? Is there any thought process on that yet? Or I mean, how we plan to work with that? So in general, fine, you've got Kubernetes and you're distributing these tasks, but is there any thought process to kind of distribute or allocate resources based on clients, because that has a commercial impact also of how infrastructure is used for different clients?
Right. Yeah, that's a good question. Actually, Prefect allows us to, the Prefect infrastructure allows us to, delegate flows based on labels. So label-based execution is allowed. Where so there is an entity called agent. So an agent pulls what agent does is it checks with the Prefect server if there is any work that I can do. An agent will have a label with it associated with it. Say client A. Now, if there are some flows registered with that particular label, a flow is waiting to be executed. This agent will be able to pick it up, and this agent controls the execution side. And we can allocate resources just for that agent, right? So we can have different priorities of
agents or whatever, and based on agents, we can prioritize resources.
Yes.
Okay, understood. Got it. So thanks a lot, Johns, for that. In fact, when we started the session, we probably didn't even introduce the topic. I think we introduced ourselves, but I think people have understood the fact that we're talking basically about performance in this. And the first part of performance was basically understanding on the cloud, for our ETL jobs, the lessons that we had in performance.
Talking about performance, what are you? I heard that you are working on performance tuning in Windows.
Yeah, it's not so much performance tuning. I think measurement and monitoring is the first priority. And I think that's the current issue. So yeah, that's part two of our webinar. Sorry, our podcast rather. I'm so as just to give the viewers a context here. So in O4S, you have the O4S cloud, right? You have real-time APIs happening. You have the ETL jobs, right, which are the transformation jobs over data, which is what Johns was talking about. Once you have the data, how do you transform it and do various things with it, including data visualization? And that's what this entire DASK conversation was about. The technologies used to do that, Prefect and DASK. But coming away from the cloud, O4S has a very strong requirement for the edge, right?
Right.
So edge devices are basically our own Windows boxes running in factory locations. And primarily, we are dealing with two major constraints. One is lack of internet or stable internet connectivity, or even bandwidth internet connectivity, which is usually taken for granted in cloud-based infrastructure and architectures. And the second issue is, apart from the internet connectivity, is the resource consumption challenge. Because remember, in a cloud, as you scale, you can always virtually add more infrastructure, right? Today, a lot of AWS, Azure, etc., give you that ability, right? For
Right. Right.
the cost scaling. I mean, that's what clouds are all about. Whereas on the edge, we don't have that luxury in a factory plant to scale their infrastructure, right? So if it's an 8 GB machine, it's going to be an 8 GB machine. And apart from just increasing the capability of the machine, which is going to cost further, right? We physically can't do it because it's a physical job to replace those machines. So what we have to work backwards within given infrastructure. How do we kind of optimize our resources on those in that infrastructure and improve that? And before we get to the improvement stage, right? I think measurement, is a very critical aspect. And measurement solves two problems, Johns. One is that it solves the problem of understanding your downtime and predicting, basically knowing a problem before it occurs or even as it occurs, rather than a client calling you up and saying, hey, by the way, your system has gone down, which is so important because we're writing mission critical applications on factory locations which are impacting production. So as we scale, we can't afford to have those kind of issues which stop.
Sorry to interrupt, Arjun. So could you explain what Edge is and what it is doing for us?
Right. So Edge, as I explained earlier, Edge is the system. The typically for now it's the Windows system. In the future, it could be a bunch of IoT devices. For all I know, but currently it's a Windows box. It's an 8 GB Windows box, I believe. We're running a Windows 10 Pro operating system, and that's put on the location of the client. The reason why we have these Edge boxes is because typically there are two primary activities that happen. I mean, there are other activities and products in the pipeline, but the most important mission critical applications are serialization and activation. Serialization, Johns, is the ability to print our QR codes on their products via labels or printing them directly on products via laser printers, for instance. And activation is once something is printed, to verify that code has been put onto the right product, so that our systems are able to give the value that we call original for sure. That means by the time it reaches the client's hands, we know for sure fact that this product is what it says to be based on the QR code. So these critical things happen on the factory floor. And as I explained earlier, that internet connectivity may be bad. So then how do you kind of make sure that things are running? And that's where the edge is so important, where it can work even in bad internet connections or no internet connections for some time, and make sure that at least factory operations don't stall in a given amount of time.
Right, right. Sounds like it's very mission critical.
Right. So yeah, coming back to performance monitoring, you talked about. So performance monitoring. So this is the context of monitoring. Now, performance monitoring can be done in many ways. But yeah, I mean, this is to your question earlier. This is exactly what we are trying to work, the business problem they're trying to solve. But yeah, if you have any technical questions, then I'd love to get into the technical nitty-gritties. But go ahead, ask the questions.
Sure, definitely. I have a lot of questions for that. So you said process monitoring, right?
Yeah, that's right. Performance and process monitoring, right?
How is it different from telemetry?
Okay, so telemetry is more engaged with how your code is running to identify a problem in which container the problem occurred. So telemetry is tracking real time how your code or your application is running. It's application level data, right?
Right.
It's very useful, especially if you've got a Kubernetes cluster and you're scaling dynamically, you've got multiple containers, and those containers are handling stateless requests, and you need to track, right, across the logs, which process did what. Now, I'll give you a small example. In traditional programming, developers write logs all the time. If you've got concurrency in the mix, guess what's going to happen? Thread A is
Mm.
writing log A, thread B is writing log B, but the flow of that particular thread is lost, A. Now compound this problem with multiple containers doing their own thing and then aggregating those logs. So the entire, it gets very difficult to understand these logs and monitor these logs and even make real-time sense of these logs. And as people scale, I think how you understand your applications running is very important. So telemetry is that, right? It basically gives you a lot of insight into aggregating how your applications are running. However, the challenge that we are facing right now is not going to be solved by telemetry, right? Because most of the applications, before we started, what we did was we had a goal of saying we're going to reduce our operational inefficiency, say by 80%, right? But before we did that, I always believe in start, you define your goal first and you measure and then you act. So when we measured what kind of issues you're facing on the ground, most of them were to do with either operational issues, right? Or things like MongoDB going down, right? Or basically operations not able to kind of understand why a process was not running. They were to do more at a process level of processes failing or not working, rather than the code not running. And in fact, there were very few bugs in the fire effects. We have a channel called Fire Product where, there's an escalation, developers jump onto it. And by measuring the pipeline of issues coming in that, literally, I could say roughly 80% are to do with the processes running or misunderstanding on how they should be run. They have nothing to do with code. The second thing by telemetry on the edge is a nice to have and not a necessity, is that on the edge, your single instance, it's a single container generating single logs, right? You don't have the problem of having to aggregate all the logs of the applications running across various containers. It's not a problem that must be solved. It's nice to solve it, but compared to that, monitoring is more important, right? If I have 20 client locations, which of my computers edge locations is down and which of their databases is down, or if you're running 5 services on them, which service is performing poorly, that is more critical at a high level for operations and business than is telemetry. So I hopefully I've been able to explain your answer without, yeah. So yeah, that's
Right, right. And I guess telemetry is also a little hard to implement without affecting productivity for such an evolving product.
Yeah, telemetry requires code changes also, right? And you need an open telemetry server. You need to basically have a telemetry agent where you need to modify the changes in your code because you're measuring code spans within the code. Now, coming to even I didn't mention that part earlier because even in performance monitoring, there are two ways of doing it. There are daemons actually which run, they're standard daemons. And one way is intrusive, which is you modify code to take out performance metrics from the application. And the second is you do it at the operating system level. So I am more in favor of doing it non-intrusively from the operating system level. So yeah, and there are reasons for that, but I'll just go ahead with your questions for now. Yeah.
Sure. So in this, it looks like IoT has been there for a while, and this must be a problem that the industry must have faced a lot. So I'm sure there must be some practices or tags or some frameworks just to solve these kind of problems. So are we exploring those?
So I don't think frameworks solve problems. I think frameworks solve a particular part of a problem. And the real issue as an architect that you have is how do you piece together the solutions end to end in an ecosystem to solve the problem that is custom to you, right? So
Right.
while IoT has problems, people have standard things, and we are using those code, frankly. And just to your example earlier on, where you talked about people writing custom schedulers, etc. But I won't be too hard on people writing their own code also because time is an issue, constraints are an issue, right? And even to your example earlier, Johns, when we were talking about DASK exists, right? But it is the application of DASK and prefect which is the problem, right? So
Right, right.
it's I'm gonna answer your question technically also. But before I do, it's very important to explain this to people who are developers or future architects or other people. Don't be hung up about the technology you're planning to use, right? Because it is not technology, but the depth of how you understand that technology and how that technology interplays with another technology. Again, every architect has their own way of thinking, but my personal opinion has always been that you have to look into the maintainable aspects. You have to look into systems rather than kind of jumping and reconstructing everything. You have to look into how the ecosystem will evolve, what will be the knowledge curve for developers and operations engineer to adopt what you're suggesting and building, right? So it could be the best technology, but if the knowledge curve is very high, it means that your depth of knowledge of the system will be very poor, and that is a guaranteed for failure, right? So there is no, it so much depends on your own people understanding their capabilities, their engineering skills, the organization is aligned to which technologies, right? So for instance, even you chose DASK because DASK was Python based, right? O4S has not invested in Java, otherwise probably you would have gone with Apache Spark, right?
Probably.
So so many emotional decisions influence practical decisions, right? And
Right.
it's very important to understand that. Now coming to IoT itself, which is your question, yeah, I think so. We are using standard components. So those standard components there are daemons that exist that do process monitoring already. So we don't need to reconstruct those process monitoring tools. There are, to name few examples, there's CollectD and there's StatsD, which are people can review online. And then there is FluentD, which is basically a log aggregator. And then there is MQTT protocol, which is, I think, ideally suited for O4S, which has not been so far used for O4S, but is widely used in the IoT community. And I think it's something that I would be introducing via the Health Metrics API to communicate with the cloud. So these are some technologies that I'm using. But even within these technologies, there are lots of options, and we have to kind of put them together. And yeah, but maybe through your next questions, I'll talk about what those options and how they're put together.
These components that you just mentioned, are they, platform specific, or, can we reuse it across platforms?
So CollectD and StatsD are conceptually platform independent. They exist for Linux as well as Windows, but for Windows the implementation is different, right? And there are differences in their implementation. So no, I mean, because the like I earlier talked about, is you can have monitoring, excuse me, at a non-intrusive into code which is running at the OS level, or you could do it at the code level, right? If you
Right.
want platform agnostic, you probably would want to go for code level, but then again, then you have to modify the code for that, right? And it's part of the code. It may increase the, again, depend on the implementation of the code. It may increase the footprint and may be written badly where, because another constraint in the architecture is you don't want the performance measuring or monitoring tool to add to the performance constraints and issues. And initially, prematurely, if you do it via the application, right, then you're risking doing that because the other engineers don't have that sensitivity to that. So again, coming back to the question that you asked, that because we are going for the OS specific implementation earlier on, right, for the reasons I mentioned, the
Yep.
OS are OS specific, though conceptually they are common, but implementations are very different for Linux as well as Windows. And in Windows, actually, the entire performance monitoring architecture of Windows is so different from Linux that the solution is completely different. Yeah.
Okay. You mentioned MQTT, right?
Yeah.
So could you elaborate on how you'll be collecting data from where, and how it would be going into a cloud?
Sure. To explain this, what I'm going to do is I'm going to share my screen,
Yeah.
and just let me know if you can see my screen. 1 second. I haven't shared my screen yet. Okay, I'm going to share my screen. All right. Can you see my screen now?
Yes.
All right. So the plan roughly is that, so as I said, like based on business priority, the most important thing in the next couple of months, I would say, the first 2 quarters, I would say, is that we are doing performance service level performance monitoring, right? Which is basically CPU, memory usage, disk IO, possibly network IO, right? Measuring that via the operating system, right? And that's where in Windows offers two services, collect win and SSC serve. Unfortunately, SSC serve has a licensing issue. It's not open source, though I prefer it because the collect people who've written it for Linux recommend SSC serve. But however, we'll see whether the licensing. It's not that collect win is also bad, and again, it requires
All right.
research to validate the how good something is. So for
Right.
now, because of the license restrictions, I'm going with collect win first, and I'm exploring that. Now coming to MQTT, which was again your question, but I slightly deviated because I'm showing this graph. I apologize
Sure, sure.
for the deviations. There has to be an agent. You see, the problem is that Collective Win they have something called input and output plugins. These services, and these input and output plugins are limited, right, in terms of what they can do, and none of them support MQTT directly. So we will need an agent, and I'm trying to find an agent, but it doesn't exist. So I might have to code this, which would be a shame, but I would have to code an agent which would basically take the data from CollectDWin and then push it via MQTT to the MQTT broker. Now, why are we using MQTT? See, when you're dealing with cloud networking, the network connection quality is nowadays considered to be very good, right? I don't think you code for network issues anymore, right? But when you're dealing with IoT devices, and especially in our case, IoT, where internet is an issue, right? And we depend on the internet for intermittent transmission of data. We need at a protocol level. So currently, like we're using HTTP REST, but HTTP is susceptible to connection breaks. It is a request response mechanism where if there's any delay on the server side, your entire request payload, your entire response payload could be useless. Again, there's a way of getting around that, which is you could use HTTP to live streaming, but that can be explored. However, again, I'm a big fan of gRPC, but again, gRPC is HTTP based, whereas MQTT is TCP based, right? And it serves a more underlying protocol in the OSI model. It serves the need. It was designed specifically to transmit very minimal amounts of information over poor bandwidth conditions, and it has the ability. The protocol itself takes care of the ability to basically handle connection issues, basically, right? And it doesn't have a security layer of its own, and you can actually configure TLS over MQTT. But TLS is usually over HTTP, so I've forgotten that part, how that works. But anyway, maybe MQTT also works with HTTP, but I think I've messed up on that one. But anyway, it doesn't matter. The basic thing is that MQTT is designed for exactly the problems that we're facing between our cloud and our edge locations. And my endeavor would be to use a low intensity daemon, which is not contributing to the resource consumption of the edge, and relay that efficiently to a lightweight MQTT broker, which will also be on the edge, and then transmit that to the cloud. And on the cloud side, we're using Kafka. So someone would write a Kafka agent, not me, but someone would write a Kafka agent to basically subscribe to the data, and it's a pub sub model basically. So these daemons publish the data to MQTT, which acts as a kind of temporary store, and it kind of releases it releases the data to the subscribers whenever the internet connection is good, basically. So that's basically how this entire conceptually how this is supposed to work.
Okay, these MQTT brokers and servers, we will need to install on the Windows machine itself, right?
Yeah, so what you need is an MQTT server, which you need to install on the Windows machine itself. Because the reason why it needs to be installed on the Windows machine and not the cloud, which could be a question, where do you install the MQTT broker? Look, the daemons are continuously producing data. So there's a concept of consumers and producers, right?
Okay.
So for instance, people who have used resource monitor in Windows, or performance monitor in Windows, or even task manager, right, where you're seeing the threads. Actually, these are not querying the operating system directly. The way Windows performance architecture works is that they use a performance data handler, PDH.dll typically, which generates the event data, and then these tools consume the data. So typically your task manager and your performance monitor are consumers. The daemons are the producers. Now the problem is the producers don't persist the data. Their job is just to generate the data, right?
What about tools like event logs in Windows?
Event logs are also consumers, but they're not capturing telemetry. I think event logs are not necessarily, I mean, events can be generated from a variety of sources, but yeah, they could also tap into the PDH, the events, which is the V2 version of the Windows performance architecture. In fact, let me share that with you also. Windows, so earlier on, Windows had a P1 provider DLL. They had a V1 architecture and V2 architecture. I think Windows 7 onwards, I think V2 came in. I'm not quite sure on the details of that. But so what happens is there's a consumer code, right? So this is like your resource monitor, whatever. And earlier on, the data would be published in the Windows registry, and there would be a registry API that would fetch the data. This is the old way of how Windows used to collect performance data. In the new way, your process basically publishes the data, right? And these are known as PDH counters, right? And they cover everything, every kind of event that you can think of. I mean, CPU and memory are just like, skimming the iceberg. In fact, let me get into performance monitor. I can probably show it to you while we are talking about this. So performance monitor is a consumer, but the events being generated by performance monitor are basically, so I have defined a custom data set here, right?
Yes, yes.
Okay, fine. So what you can see is, so this is how you can, and this is a very useful lesson for people who want to do in general do performance monitoring on Windows. But like performance monitor, like I said, is a consumer. It's not the generator of data, right? But using performance counters, you can cover like all sorts of events and metrics that Windows provide. And it's crazy what the list is endless. And these are known as performance data handlers, PDH counters typically, or performance counters in Windows, and they cover a host thing. So there's usually a path. Each of these selections results in a path. So if I want to kind of check how much memory Chrome is using, the path, the PDH path, performance counter would be process Chrome. And again, the star here means all Chrome instances, or I could specify a particular Chrome instance, and I could say private bytes, and that would tell me the memory consumption of that. And percentage processor time is basically converting the processor time into percentage for all Chrome instances, right? So this is how detailed it is. And Windows is able to kind of basically give you performance counters. And then what you do is you tap into these performance counters and with an interval, and then you basically capture that data, right? So again, remember the performance mon tool is a capturing tool. So we're not obviously going to be using this because this requires you to be running. I mean, if there was a problem in the system and you needed to debug it, this would be a great way of doing it. But what we want is to 24/7 monitor our systems, for which we need our own daemon running in the background with these kind of performance counters in the configured, and then transmitting that data via MQTT to our cloud, this thing. But by seeing this, what I'm showing you is how Windows kind of shows performance data, right?
So
And
you're saying that there will be consumers, which will be written by ourselves. The daemons will be collecting data from the PDH.
Yeah, I mean, we don't need to get it. It's the Windows performance architecture, which PDH is a part of that. But yeah, the PDH counters, the performance counters, they are, I mean, we don't need to get the technical thing, but they are typically known as performance counters. And these performance counters are basically like paths, right, which specify exactly what do you want to measure. And they can be very specific and very detailed in Windows, right?
Okay. Aren't these getting persisted anywhere by default?
No.
Or is
So
there any
again,
configuration?
into your question, no. So see, the thing is, the job of Windows is to generate these events. It is the job of the consumer to capture the events.
So what about syslog or event logs that Windows is persisting? They are also consumers, right?
Well, a couple of issues, right? Like how do you send? So I'm going to stop my screen share because nothing else for me to show right now.
Yeah, sure.
So your syslogs and your Windows logs are basically going into your Windows system. Eventually, you'll still have to read them and send it to the cloud, right? So why not tap the data at source and send it to the cloud? Then kind of that. But then the issue that you have is how do you aggregate this file? So cheap solution could also be I could use performance monitor to generate CSV files. So performance monitor is capable of generating CSV files. But then again, you have the issue that you have to aggregate the CSV files eventually and transfer it to the cloud, right? And then again, you're probably going to do that through HTTP. There are going to be files over lot of performance. Your files will get bigger. You have to zip them. You're spending too much effort on not the core issue, right? The core issue is get the data and stream it to the server directly in a reliable manner. So
Got it.
I'm just focusing on that. So any kind of file-based solution is, I don't think, going to be optimal, because you're going to then have to deal with other problems which are not even core to the issue you're trying to solve.
Got it. Got it.
Including on the cloud, once you get those files, let's just say worst case, you say, okay, let's load it on the S3 bucket. You have to then kind of write a job to aggregate the data through S3 eventually, right? So, I mean, it's just too much overhead for no reason. Just take it through MQTT, put it on the cloud, put it on Kafka, consume that data real time, then, put it like through Grafana or wherever you want it, Elastic. I mean, that you guys decide on the cloud. I'm not really involved right now at that stage much, but yeah, that's the consumer's responsibility then. Yeah.
So do you want to, have you thought about, transforming this into time series data on the machine itself?
So yeah, again, see, that is a possible solution. So if I wanted to make my work easier and I was lazy, even though I'm Goa and I would love to chill, I could use a time series database. But the problem is, again, it'll create two problems. One is you need to install a time series database anyway, which is adding overhead to the edge system, right? And I'm not quite sure. Again, I don't do anything without research. I'm not quite sure what overhead the time series database would have, on the system.
Right.
And B is that eventually, once the data is in the time series database, you still have to synchronize it with the cloud. So you really haven't solved the synchronization issue, right? So my question is, and the third thing, by the way, is also that even if the time series database in the best case scenario did not consume much RAM or CPU, it will consume disk space, right? And even disk space is a resource that is premium to us. And I would prefer, and this kind of also answers other questions about creating files and logs on the system to measure performance activity. I would prefer not to persist this data any longer than it is required until an internet connection is gained, and MQTT does that beautifully. So why would I want to consider any other solution?
Sure. Fair enough.
Yeah, but having said all this, I have to say that there's a lot of research going into each component. So again, while the higher level design goals have been researched, I think there's a lot of work yet to be done in terms of piecing this together. And I'm still far from my goal, but hopefully, being away from the crowd will allow me to focus and get this done. So I'm really excited. But yeah, and also I think the benefits of this and using MQTT can then later be applied to our main application synchronization process, where we currently are relying on traditional HTTP request response protocols. Even if we don't use MQTT for that scenario, I think we should definitely use HTTP to live streaming for that case. But that's a different topic, like I said earlier on. Yeah.
Cool. And in the background, I have this question in my mind. Like, why do we have Windows in our IoT? Why do we use it as a machine in our facilities? Why not simpler machines like Linux, which will make a lot of our tasks easier?
I don't know, man. Maybe Linux is simpler for you. I grew up on Windows, so I just prefer Windows. No, I'm just kidding. That's that's not the answer. But so okay, so the reason for using Windows, and I don't. I think this is a hot topic and debatable topic. But though since this is our podcast and I can say what I want, so I will say this very loud. I think Windows is not going anywhere from the edge system for many reasons. Typically, it's only, and I've interacted with actually developers from Adobe also, who officially at some point did not support Linux. We have a component. There are a couple of factors. One is the graphic drivers of Windows and Macs are far superior to that of Linux. Okay, even till date. Number one.
Okay.
And when you are doing printing, like we are using softwares like glabels, etc. And a lot of people using their middlewares also. Their templating softwares are very GUI driven. Because the edge is very GUI driven even till date, Linux is not the right choice from a user point of view. Forget technically, right?
Okay.
It's not right. You would have to find an alternative for every software, and that's just because you want to use Linux, you're justifying replacement of software. I don't think that's, in my opinion, a great way of doing things, right? And Windows is not that bad, frankly. I know it's over the years it's got a bad reputation, but they've done some incredible work. And I think they are doing some really good work. And with the future versions of Windows, you can expect more stability. But first is the most important reason is, I feel commercially, for a lot of clients, the softwares that they're using have Windows support, including their middleware softwares, which are GUI driven, which is not available on Linux, right? Number one.
Okay.
Number two is that a lot of these machines have to be run by operations engineers, right? Our operations staff and even the client sometimes. And Windows is intuitively something that people find very easy to use, except developers, of course. And that's why I started with the joke saying that maybe for you, Linux is easier, harder. Because I
Right.
empathize with the end user, and the end user is not a Linux user, right? So as long
Yes.
as, again, we as engineers have to think who's using the system, right? Developers are not using the system, right? Who's using the system? Let's answer that question, right? On call. It is
Right.
the consumer or the operations people. Do you think they'll be comfortable using Linux at all? No, right? So
Yeah.
even from a usage point of view, as well as a technical point of view in terms of the software support required, I don't see why Linux is a better choice technically. And even if you had to replace it, it would take ages. And I don't see why the effort is justifiable. Yeah, if you were writing very task specific hardware, you could use Linux on a Raspberry Pi, but we're not doing that, right? Currently, we're using MongoDB, we have GUIs running, and wherever, I mean, and you can't have, again, people can argue you can have web based GUIs, but a lot of our GUIs are desktop driven GUIs, which require, the support. And moving away from Windows, I don't see as an option right now. But that's the reason why we use Windows.
Beautifully put, Arjun, as always. Is there anything else that you would like to highlight on your focuses right now?
No, I think there's just a lot more work to be done. I think what I've explained is just the tip of the iceberg. I don't know if you're out of time. I think, yeah, but yeah, that's pretty much it from my side so far. And yeah, I'm looking forward to implementing these things. Yeah, and I think the end aim is for our operations guys. Now I want to talk. Actually, I do want to talk about a topic which is psychology. You know.
All right.
So while working with O4S very recently, we tried to kind of create scripts, which will basically, and this is a lesson which is slightly off topic, but I wanted to share because it comes under the edge domain. So we tried, and we're still trying because we're not going to give up, because of initial obstacles. But what we were doing was we were, trying to create scripts that operation folks can run rather than calling developers and saying this is not running. I'll give you an example. If MongoDB is not running, why should they have to call a developer? They should be able to run a script that can run some, tasks to kind of figure out why MongoDB is not running and get it running. And I think we've been successful in doing so, actually, from a technical perspective. But psychologically, what I noticed was that even though the script was available, right, the operations folks were not comfortable in running them. And this is why, personally, even from an architecture point of view or goal perspective, the operations people are my customers, right? Because if they are not comfortable running something, then it doesn't matter how great a technical solution it is. And that again answers the Windows question also that you had. It is their comfort comes first, because if the operations folks are comfortable in running something, right, then that's when we can scale, right? That's when we can have more people on the ground just running tasks and focusing on operations rather than having developers solving operational issues on those boxes. So one of the psychological issues and impacts is that even though we are producing solutions, I think it'll take time for operations to adopt it. But I think my request to everyone is that when these solutions come out, that the operation folks are on screen shares, they are seeing the developers use these solutions so that they get confident, but they slowly start using them, and eventually the solutions that we provide them, the tooling that we provide them, the tool sets that we provide them, they are comfortable running themselves, via again, I think the other products like Eagle, Dawn, etc. coming, which will give operations more power at the grassroots level, and kind of make the developers' jobs easier also, where we can enjoy our holidays and not be called for an operational issue.
Right.
Yeah,
You're right, Arjun. Like product, we can be considered mature only if non-developers can maintain it. Right.
Correct, exactly, and that's where we are heading. So that's, it'll take time, but that is the effort that's going on also. Yeah. So that's everything under my plate, Johns. I really have nothing more to add to this topic.
No, thank you. You added a lot of value to this podcast. I think it's time to wrap it up.
Yeah, and thanks to you also, Johns. I mean, for your experience at O4S, and now you're working on the cloud. So we will be working together because the edge and cloud have to interact. So yeah, looking forward. And thanks a lot for your experience and input also to this podcast, man. Thank you so much.
Thanks, Arjun. Let's say to our viewers to like, share, and subscribe to this video. You can expect more videos on a weekly basis from us. And if you have any questions or recommendations for topics, please do it on our comment sections below. Thank you. See you again.